Hello everyone, welcome to my channel One Concept EE. This is one of the DC machine question. The main concept used in this question is magnetizing characteristics of DC shunt generator. Magnetizing curve of shunt generator. Let's solve this question. Here the data given is the EMF developed in armature shunt generator at speed of 1155 rpm is 240 volts at a field current of 4.5 amps. Similarly, if the field current of 5 amps, it is producing an armature induced voltage of 255 volts. Now, this generator is now operating as a motor at a terminal voltage of 260 volts in an armature, and it taking an armature current of 75 amps. They are asking to find motor speed if the field current is adjusted to 4.8 amps. Means at the field current of 4.8 amps, what will be the motor speed if the terminal voltage is 260 volts? Along with the given the armature resistance of a DC shunt machine is 0.12. Let's write down the data. It is given it is a DC shunt generator, and in the case 1, if it is taking a field current of 4.5 amps at the speed of 1155 rpm, the EMF generated is 240 volts. Similarly, in the second case, the field current of 5 amps at the speed of 1155 rpm, the EMF generated is 255 volts. They are asking to find if suppose the machine operating in a motoring condition at the field current of 4.8 amps, what will be the speed? Before going for a motoring condition, in generating condition only at the field current of 4.8 amps, what will be the EMF generator? Let's find out this one earlier. Let's draw the magnetic characteristics of DC shunt generator. Here at the field current of 4.8 amps, it is generating an induced EMF of 240 volts. If the field current of 5 amps, it is generating induced EMF of 255 volts. Now they are asking to find at a field current of 4.8, what will be the induced EMF. We are assuming this curve is a linear curve. Let's find slope of this curve. Slope is y2 minus y1 by x2 minus x1. Here y2 is 255 minus 240 by 5 minus 45. They given a slope of 30. Equation will be y minus y1 equal to m into x minus x1. Here y axis is an induced EMF, x axis will be field current. By substituting this, I am getting expression of induced EMF equal to 240 plus 30 into IF minus 4.5. At a field current of 4.8 amps, if you replace IF equal to 4.8, you get an induced EMF of 249 volts. Means at a field current of 4.8 amps and running at a speed of 1155 rpm, the induced EMF is 249 volts. Now, if suppose if this machine is operating in motoring condition, it is taking an armature current of 75 amps. Here it is taking an armature current of 75 amps and field current of 4.8 amps. We already know we can find back EMF EB equal to VT minus IRA. The terminal voltage is 260 volts, armature current is 75 amps, armature resistance they given is 0.12 ohm. If you place all the values here, you get a back EMF of 251 volts. Let's summarize the data here. In the generator condition, at a field current of 4.8 amps, at a speed of 1155 rpm, it is generating an EMF of 249 volts. In motoring condition, at a field current of 4.8 amps, there is a back EMF of 251 volts. We already know the formula E equal to K into phi into omega. Here, EG is a EMF in generator case, EB back EMF in motoring case, is a field current in generator, field current in motor. N1 is speed of generator. N2 we need to find, it is speed of the motor. N2 is speed of motor. By substituting the above values, I get a speed of 1164.27 rpm. Means if a field current of 4.8 amps and terminal voltage of 260 volts and armature current of 75 amps, the motor will run at speed of 1164.27 rpm. Here the main concept is we should calculate the generated EMF by using the slope only. Otherwise, we will end up in a wrong answer. If the question mentioned what is the slope of magnetizing current, we must include in the solution. This is a very good question. If you want to solve this sort of question, please subscribe to my channel.